When we talk of machine learning, three main kinds can be useful to know. They go under the designations of supervised learning, unsupervised learning, and reinforcement learning. Supervised learning comes into play when we have data as well as some form of known outcome. When we know the correct answer about our data, for example, if our material consists of images, this type of response can be a label that tells you what the image represents. During the training process, we evaluate the performance of the predictions delivered. The system receives feedback so that it is gradually adjusted to perform better. The second kind, unsupervised learning, should be understood in contrast to the first kind. In this case, we have data, but we lack information about any specific or desired outcome. Instead, we ask the system to examine all data to identify different forms of connections that may exist. Clustering techniques sort the data into groups that exhibit some form of similarity. This is how recommendation systems work. Take the example of music. We can define your taste in music as the sum of all artists to which you have been listening. Based on this profile, a music service will group you with other similar individuals, others with a comparable history of music listening. Among this more extensive group of users, there will be artists that you have not heard before. The recommendations to you are therefore drawn from this particular selection. The goal of the recommendation system is to offer suggestions that are both relevant and meaningful. And through this process of unsupervised learning, the system attempts to propose artists that come close to your preferences. The third kind of machine learning is called reinforcement learning, and the algorithms that make up this approach are based on a different set of principles. At the core, we will have an agent who can perform various actions in a digital environment. These actions will also be evaluated and awarded a graded reward. A good example is computer games. If we take Super Mario, we see that our agent, Mario, can run and jump in a changing world, that is, our environment. And depending on how well these actions are performed, we will get a higher or lower score, our reward. Reinforcement learning, then, involves letting a computer play several rounds of this game. We will not tell the computer what the game is about or how this problem is supposed to be solved. At the start, the computer will act entirely at random. It will therefore perform exceptionally poorly. But between each round, the system gets to update its solution strategies based on the feedback we give it. Feedback that is the reward signal. So the only thing we ask is for the computer to maximize the score. If we run this process long enough, the computer can figure out effective methods for navigating the environment and solving the problem of maximizing the reward. Sometimes it will discover solution strategies that not even humans had figured out before.